Hi everyone, it's Balram Pandingai. Today I'm going to present the Captain project on bike sharing demand prediction. And my team has 3 members, and their name also mentioned here. So going to the next slide. Uh, these are the content of our projects. So first of all, we need to know business understanding. So on which we are doing the business for for what purpose, and data summary. What are the summary of the data? Uh, Feature analysis, exploratory data analysis, data pre-processing, implementing of algorithms, challenges, and what are the challenges we faced during this project, and conclusion. So going over the next slide. First of all, we need to know what is the business understanding of our project. So bike rentals have become a popular service in recent years, and it seems people are using it more often with relatively cheaper rates and ease of pickup and drop at own convenience is what making this business thrive. As the bike rentals become more popular day by day, mostly used by people having no personal vehicles. Who the people who don't have any personal vehicles, these bike rentals are mostly used by them only, and also to avoid congested public transport, which that's why they prefer rental bikes. Because if anyone wants to go somewhere through a crowded bus traveling, so basically bus travels are very crowded, that's why everybody wants their own space. That's why they're avoiding, mostly they are avoiding the crowding traveling. That's why they choose the bike rent. They would like to take those bikes on rent. Therefore, the business to strive and profit more, it has to be always ready and supply number of bikes at different locations to fulfill the demand. Our project goal is to pre-plan a set of bike counts, values that can be a handy solution to meet all the demands. So here is the data summary. Here we have mentioned, we displayed the top 5, means this is the last 5 data data set, the data of our data set. This data set contains 8,760 numbers records with 14 instances. 3 category features: season, holiday, function day are there. One date time features date. We have some numerical types such as temperature, humidity, wind visibility, dew point temperature, solar radiation, rainfall, snowfall, which tells the environment condition at the particular hour of the day. So feature summary. Here we are going to explain the feature. What do you mean by each? What does mean? What does it mean by each and individual single feature? Year and month of the date, year and month day, and rented bike count. This is the count of bike rented at each hour. Means per hour how much number of bike is getting rented. Uh, temperature in Celsius, humidity percent, it is in percentage, and wind speed, visibility, dew point temperature. This is temperature in Celsius, solar radiation, rainfall, snowfall, seasons. Seasons, there are 4 seasons are there: winter, spring, autumn, and summer in our data set. Holiday, there is one column is there called holiday. There just mentioned 2 type of data is there: one holiday and another is non-holiday. Function day, it is also the same. It's a function day or not functional hours or functional hours, like that. So insight from our data set. So we need to look what are the hidden patterns, hidden insights from our data set. So there are first we need to check there is no missing values, duplicate values are not there, null values are also not there, and finally we have rented by count variable. We need to predict for new observations. The data set shows hourly rental data for 1 year. That is from 1st December 2017 to 31 November 2018. It is around 355 days. We consider this as a single year data. So we convert the date column into 3 different columns, that is year, month, day. So we change the name of the some futures for our convenience. They are as below. They are mentioned here: rented by count, our temperature, humidity, wind speed, visibility, dew temperature, solar radiation, rainfall, snowfall, seasons, holiday, functioning day, non-functioning day, month, weekend, weekday. Now analysis of rented bike column. There is a column called rented bike count. So here we are going to see how much number of bikes getting rented per hour in every hour. So the above graph shows the rented bike count has moderate right skewness. So the above box plot shows we have detect outliers in rented bike columns. And since the assumption of linear regression is that the distribution of independent variables has to be normal, so we should perform square root operation to make it normal instead of that outlier treatment. So as in linear, we are going according to a linear regression assumptions. Analysis of rented bike column set. So after applying square root to the skewed rented bike count, here we get the most normal distribution after applying square root to the rented bike count. So we find there is no outlier present. Like that, we are going to analyze the month variable. So here we have plotted one bar graph. So from the above bar plot, we can clearly see from the month 5 to 10, the demand of rented bike is very high as compared to the other months. These months are come inside the summer seasons. So weekdays and weekend, we have changed the column name to weekdays to weekend. So here we have plotted one subplot here from the above point plot. We can say that the weekdays which present in blue color and shows that the demand of the bike is higher because of the office peak times are 7 a.m. to 9 a.m. and evenings 5 p.m. to 7 p.m. So the orange color presents the weekend days and it shows the demand of the rented bikes are very low, especially in the morning hour. But when the evening starts from 4 p.m. to 8 p.m., the demand is slightly increases, but it's not increasing as it is not as compared to weekdays. Like that same, we are going to analyze the hourly hour variable. So from the above, so this bar plot, shows the 24 hours of one day. So here we can see generally people use rented bikes during their working hour from 7 a.m. to 9 a.m. and evening say 5 p.m. to 7 p.m. And in these two times only there is a high increase in the rented bike count. Means the demand is high at the time of morning 7 a.m. to 9 a.m. and 5 p.m. to 7 p.m. So analyzing of functioning day variable. So here the orange color shows the non-functioning day and the blue color shows the functioning day. As it is non-functioning day, so the demand, so the count of rented bike, the rented bike is zero because of no function, because of no, that may be no working, that may be leave, that may be holiday, or whatever it may be. But there is no rent. Now coming to the analysis of season variable. So as we have already, as I have already told that there are four seasons are there in our data set: winter, spring, summer, and autumn. So out of them, in summer season and autumn season, the rented bike count is very high. But in winter season, the people don't take any rented bike due to because of low temperature and because of snowfall. Many more reasons are there. Because of that only, maybe people don't like to take bike on rent during the winter seasons. Here we can clearly see these are also the point plot. The same timing is there because as I have already told, the count of rented bike is very high during morning 7 a.m. to 9 a.m. and evening 5 p.m. to 7 p.m. Here also I mentioned the same thing, and here we have plotted the point plot. In this point plot, this green color shows the winter season, and orange color shows the spring, blue color shows the winter, green color summer, and red color autumn. So in this we can clearly see during the summer season the count of rented bike very count of rent The count of rented bike is very high. Uh, and after that autumn and their spring season is there, but during the winter season the count is very low. So this is the holiday variable, so people mostly don't want to take the rent take the bike on rent during holiday. So in actually they're taking the bike on rent on holiday also, but there is a specific time is there, so 2 p.m. to 8 p.m. But in not a holiday time, uh, the bike is getting the bike rent is getting high as usual. So as we have already told, the morning 7 to 9 a.m. and evening 5 p.m. to 7 p.m. So the peak time is same here. So here numerical what's a rented bike. So here we have compared each and every independent variable with a dependent variable. Dew point temperature here. From the above, we have seen that people like to ride the bike when it is pretty hot, around 25 degrees centigrade in average. When the temperature 25 degrees centigrade average, the rented bike count is getting increased. And the dew point temperature, when the dew point temperature is 10 to 20, it's getting increased. And from the above plots, you can see the amount of rented bike is huge when there is a solar radiation. The counter of the rent is around 1,000. Here is also mentioned the other independent variables like snowfall, rainfall, and wind speed. Here we can see when the windfall is when the snowfall is 4 centimeter, the bike rental is much lower snowfall. And when the rainfall is 20 to 25, it's getting higher. And the wind speed also, when it is 6 to 7, 5 to 7, it's getting higher. The rented bike count is getting higher. Here are the regression line for plot for numerical variables for temperature, humidity, visibility, wind speed, dew point temperature, rainfall, snowfall, solar radiations. So regression plot for numerical. So from the regression plots of all numerical features, so we see that the column temperature, wind speed, visibility, dew point temperature, solar radiation are positively related to the target variable, which means the rented bike count increases with the increase of these features. But rainfall, snowfall, humidity, these features are negatively related with the target variable, which means the rented bike count decrease with these features when these features increases. So these are inversely proportional to each other. Here we have built an OLS model, and the R square and R square are near to each other. 40% of variance in rented bike count is explained by the model, and p value of the deep temperature and visibility are very high, and they are not significant. So they are not significant in nature. Here we have plotted the correlation plot. So variable like dew point temperature and temperature are highly correlated, because here we can see the dew point temperature and the temperature are 0.91. So 91% of correlated, they are correlated with each other. So coming to model building, we have built more models here. So built models like linear regression, lasso, reeds, decision tree regressor, random forest regressor, gradient boosted regressor, gradient boosting regressor with grid search CV. So here here are the train and test result of the linear regression decision tree, and lasso reeds regression, elastic net regression, and a random forest for train test we have taken. And we have also plotted here the feature importance. So here, as we can see, the temperature, humidity, and functioning day, these features are more important than others. In gradient boosting also, the same thing, these three features are more high as compared to others. Here the train R square result is 0.87, and R square is for test set result is 86. So it clearly seems that there is no underfitting or overfitting. It is clearly fits our model. Now challenges. So what are the challenges when now coming over to the point? What are the challenges we faced during this project? So larger data set to handle. This is a very huge data set. 8,760 records are there. You need to plot lot of graphs to analyze. feature engineering, feature selection, optimizing the model, carefully tuned hyperparameter edge, it affects the R square value. Now conclusion. So hour of the day holds the most important features. Bike rental count is mostly correlated with the time of the day, as it is peak at 10 a.m. morning and 8 p.m. at evening. Yeah, because that may be the office time, office going time, or maybe returning time. Because of that only, the counting of rental bike is very high. So we observe that the bike rental count is very high during working days than non-working days. Yeah, obviously, because working days, more a lot of people are going there out of their houses and going to their work sessions, or anywhere else during working time only. The count of the rented bike is getting high compared to non-working day. And people generally prefer to rented bikes at a moderate to high temperature and when little windy. So if the temperature is getting more high, more low, or the count of the rented bike is getting low, it is observed that the highest number of bike rentals count in autumn and summer seasons, and the lowest in winter seasons. So we observe that the highest number of bike rentals on a clear day and the lowest on a snowy or rainy day. We observe that with increasing humidity, the number of bike rentals count decrease. So when the temperature, there is a moderate to high temperature, there is a increase of rented bike count, but when the humidity increases, then the rented bike count is getting decreased. When we compare the root mean squared error and mean absolute error of all modules, random first regression and gradient boosting with grid search CB gives the highest R square of 99% and 95% respectively for train set and 92% for test set. So finally, this model is best for predicting the bike rental count on daily basis. So we'll prefer these models because as we are getting the high R square value and the more accuracy. So we are going to prefer these two models among all models. So here we have plotted a table to show the R square values of both train set and test set. So in train set linear regression, it's 0.77772, where in test set it is 0.78, and in lasso regression it's 0.40, around 40%, it's 38%, and in ridge regression it's 77%, while it's showing 78%. Elastic net regression it's showing 62%, it's showing 62%, but there is a difference of 0.2 is there, 0.2% is there. And dissenting regression it's 16% accuracy, while in test set it is 64.8% accuracy is there. And the random forest regression, R square value is 0.990, it's 0.921 in test set. Gradient boosting regression 0.879 and it's 0.86. So among all these models, we found that the random forest regression and gradient boosting with grid search CB gives us the best fit model for predicting a bike rental count on daily basis. So thank you. That's all from my side. Thanks for your time.